So this is a common factoring question, and they're asking us for what values of k can we find a common factor in our first, so we'll call it our first expression, but not in our second expression. Okay. So we're looking for numbers that would allow us to take a common variable out of the first expression, but that same k value would not allow us to take a common factor out of the second expression. Okay? So we'll go through this. We'll try a couple. What looks like a factor of 6 and 12? What are some factors of 6 and 12? Okay, so let's write down a whole list. 2, 3, 1, okay. 1, obviously. 6, good. 12 is a good one, too. I know it's not technically a factor of 6, but leave those. What about factors of 6 and 4? Obviously, 1, 2,
3.
Anything else? That's pretty much it, right? There's not much else we can take for that. So, right off the bat, this allows us... We know that if we put in the value of 1, well, you can obviously take a common factor out, but we don't count 1 really as a common factor, because it doesn't change anything. Okay, so we're not really going to talk about that one being a common factor in this case. So we'll take our 1 out. If we were to replace k with the value of 2, can I take the same common factor out of both expressions?
Yes.
What is it?
2.
2. We can take 2 out. So that actually doesn't work for our purposes. We want one that fits into here, but not into this one.
Oh, okay.
Okay, so 2 is not going to work.
3.
So 2 won't work for us. What value can we put in?
3 or 6.
Okay, if we put in 3, what common factor can we take out of here?
2.
We can take 2 out. And the first expression, if I replace k with 3, what common factor can I take out? What number? 3. We can take the number 3 out. Can I take the number 3 out of the second expression when it's there?
No.
No, because it's not a factor of 4. So 3 is one of the numbers that works for us. It works in this expression, but it does not work in this expression. So that's fulfilling what they're asking us. That's one of many examples. Let's go with another one. And again, we said positive 3. What if we were to put in the number 6? Does 6 fulfill what we're looking for?
Yes.
Yes or no?
Yes.
Yes? Okay. Let's write 6 down and talk about it. If I put the number 6 in for k, what common factor can I take out of here?
6.
6. We can take 6 out. Okay. If I put 6 in here, what common factor can I take out? 2. I can still take a common factor out. It's not the same one, but I can still take a common factor out. So that actually does not fulfill our purposes here. Okay? So 6 does not work. Take out 6. Is there any other numbers you guys can think of? There's one in between 6 and 12 that would probably work very well. 8 will still give us a common factor of 2 in both. Why 9? That's what's very important here. Let's look at the number 9. For 9, we could take out what as a common factor into the first one?
6.
Not 6,
9.
but 3. We can take the value of 3 out from all of them. Can we take anything out when this is 9, this value? No. So, in other words, anything we have a multiple of 2 won't work because we're able to take the number 2 out in both. But any type of factor of factor of 3 tends to work. We just have to make sure it's also not a factor of 2. Okay? So, the number 12, will that work for us?
No.
No, because you can take 2 out, right? 2 has a factor of 2, so it works for both of them. But what about 15? 15 works. We can take 3 out of 15 where we can't take 2 out of 15 in this one.
18 also.
Okay? So essentially the difference is there's an infinite amount of numbers as long as we go through the multiples of 3 and we choose the ones that are not multiples of 2. Does this idea kind of make sense?
Yeah.
Okay? Because in the second example, we can constantly factor out the value of 2. We can't really use even numbers. So we have to use all the multiples of 3 that are not even numbers. And then we can go on forever and ever.